Hi everyone, Assalamu alaikum. This session is about a tool called Tinkercad. This tool is really good for simulating circuits and using Arduino and uploading the code without having the actual software. So it's going to be good for all kids gonna join us on February 20th for the workshop. And also for the remote kids that gonna follow us. So I'm sure you're not gonna have the hardware to use and tinker with, but with this tool, you'll be able to actually mimic and do exactly what I'm doing in the workshop. So I want you to just go to Google and just type Tinkercad, download. Um, and you're gonna get to just click basically on let's say if I go here, um, I already installed it, so I have the software already. All you have to do is the put your email and password to sign in, and that's it, and you're in. So once you are in this page and you have access, just like I did, um, you go. So you see I have Bijaj, that's my username. And I'm logged in right now. So when you log in, you have a page similar to this dashboard. Okay. So under 3D design, I want you to go to circuits. You click on circuits and create a new. See that? Just create. These are a few circuits I was just playing with. So create a new. Okay. It depends on your internet. The page could load fast or. So here, this is the area where you're going to be doing your design. And to the right, that is all the components that you need. So I will just select, instead of basic, select all components and just drag and drop a component that you need. So this is a resistor. It has a value of 1K. This is a kilo ohm, okay? But in the workshop, I will tell you why we need to change this value and make something like 220, for example. This is just to demonstrate the tool and make sure to change the units. So here is our ohm, and note that the color changed, and I will talk about this also. They are color coded. So I have here on the resistor. Let me just zoom so you can see it. So you have red, brown, and a gold. So the first bar here, as we will see, it's number 2, and the second color, which is the same red, is 2. So this is represent the first digit. The second bar, the second digit, and the brown color, the third bar, that's the multiplier. So you multiply these two by 10 to the power 1. This value is 1. Gold is just the tolerance. It's how, for example, this one gold is 5% of the value. So it's like an interval plus or minus 5%, just to give you an accuracy of resistor. If you just go to Google and basically Google resistor color code, click on this one, for example. So we had red, and brown, and we had calculating that we had 220 ohms. But anyway, that's not the point of this. I just want to show you this one here. Now, the second component we're going to need is an LED right here. So I'm just going to drag it here. And then we're going to need also, doesn't matter the color. We can change the color if you want. You can just go here, have yellow, red, green, just whatever color you choose for this project. So the color doesn't matter. We're also going to need, you see we have all kind of components. Here's a capacitor, inductor, diode. So we're gonna need also a push button switch, and I will talk about that also. So just to talk about this, this is just like you have at home to turn on and off a light bulb, a switch. This one is tactile a switch. It has a spring. When you push it, and you release it, it comes back again. Okay, and it's not polarized, so either terminal. So notes that I'm just going to zoom on this one here. These two pins are it's like one wire going through here. Okay, so these two are connected. Okay, these two here are connected, but these and these are not connected. Okay, so that's why we're gonna use this when we press the button here. These and these, they will be connected, and they will have like, and we're gonna have currents going through that. Okay, so for now we have a resistor, we have a diode, an LED, light emitting diode. And to talk a little bit about the LED also, if you just basically scroll your mouse, so one pin, it has this squiggly thing, and it's normally long leg. It has like a longer leg here, and the other one is short. Okay, and so the longer leg is called the anode. That's where we need to connect the positive side of our circuit to this leg here. And the shorter one, it's called the cathode. Okay, and this is where we connect to negative or to the ground. Okay, so just remember that for now. Okay, and also we're gonna need, of course, we need the power, some kind of power supply to our circuit. Let's just choose a 9-volt battery. You're all familiar with this, and you have it in your, for those kids gonna attend the workshop, you're gonna have it on your toolkit box that I will provide for you, to you. And also we're gonna need a breadboard. So let's just choose a small breadboard. Okay, for a better to create some kind of prototype and tinker with your project and idea. It's easy to have those instead of soldering resistor to an LED, for example, and this. So this is very safe environment where you can just click and drag, and you're connecting basically your components. And I want to talk a little bit about the breadboard. So the breadboard basically is nothing but a piece of plastic board with holes. And you see, when I click on one, for example, this column here, you see they're all green. Okay, means all these five, how many of them? 1, 2, 3, 4, 5 holes, they are connected together. Okay, so the same thing here. So these are connected, but they are not connected to the other ones. So each column is connected. Each hole in the column are connected. There is a metallic clip in the bottom that connects everything. The same thing goes for here. And then if we go to the top one, notice that the whole row green is connected. So this is going to be our ground or negative. The same thing for the positive side. And these two are connected here, but they are not connected to here. Okay, the positive here is connected also to all these holes are connected. So if you want to connect, for example, this and this, since they are negative for ground, all we have to do is click and then drag, and you can just make it look nice by double clicking, or just click one time, and then you can play with these nodes here to make it look nice. Okay, and you can change by just selecting the wire that you create, and you just say make it a black. Normally ground is black. Okay, we can do the same thing for, just make some room for the positive side. We can click, 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 and click here, and then we can make this one. I could have make it here also, so it doesn't look like it's cross, but they are not cross. Okay, I can make it red because positive is red. So, and you can play with it. It's really designed board. You are the boss. You do whatever you want to do. Okay. Now let's drag our components. Okay. So what we need first of all right. Let's just keep them outside. Okay. You can put them here if you want to see they are connected. But I just want to, because I want to show you something, and it's probably better to keep this LED outside the breadboard. So I'm gonna connect this leg to the ground. Okay, just click, and just to make it look like it's an extension of the LED, I'm just gonna change this to silver color or gray. And okay, so the same thing. So for this one, I'm gonna drag it somewhere. Let's say here. Okay, and you just make it look nice, gray. Okay. You need a you need the resistor in series with this LED, because the LED we're using 9 volts. Okay, and LED has some kind of voltage rating, approximately about 2 volts. And if you put a voltage, high voltage on this LED, you can really burn it. Okay, I mean, when I say burning, you're not going to make fire, but just it's not going to work. So let's choose later on in the workshop. I will talk about the Ohm's law and how you can calculate actually the value here is not right, but it will work. You know, but let's keep that value later on, and we'll talk about the resistor. So we put in series to limit the current going through the LED. So we put a resistor, and notice we did not put resistor like that, you know, because then you're connecting both. So you have to use this channel here. It's like a you know dig or something like that, like a channel in that plastic, and there is no connection. So this is not connected to that. Okay. So we have to go through the resistor to get to this LED. So a resistor, it's better to connect it this way. Okay. Now let's make our finish our circuit. Now the circuit is open. We only have a resistor going here. There is no voltage, no nothing. So drag here, and go here. Now let's make this one red. Okay. Just make it look nice like that. Okay. Now I'm gonna connect my ground or negative side to the ground here. Okay. Sometimes. Okay, now it works. So just like that, and it just changes color to black. Okay. Now we wanna turn on this. So with this tool, to simulate, because it's a kind of we're doing a simulation. Okay, we want to see the light turned on and hopefully not burned by clicking on Start Simulation, and you can see, and then it's giving a message, hey, your LED is using this value, be careful. Okay, it might not last too long. Yes, we knew that. So unstop. Okay, let's now look at if we're gonna get that message again. If we go and select this, like 470 ohm. Okay, and notice the color has changed. Okay, now okay, let's start simulation. Oh, we don't have any issue now. Okay, now we want to introduce, we want to make it fancy, and I'll tell you why I'm using a button switch right now. Let's use this switch right here. Okay, now I'm gonna take off. Okay, when you start playing with the even simulation, try to take the voltage first out before doing anything. So that's what I did. Click on the switch.